all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about instruction cycle. So, a instruction cycle is a program residing in the memory unit of a computer consists of a sequence of instructions. These instructions are executed by the processor by going through a cycle for each instruction. A instruction cycle sometimes is called fetch, decode, execute the cycle. And it is the basic operation process of computer in which a computer retrieves a program instruction from its memory that determines what actions are there in the instruction, dictates and carries out these of instructions. So if I am taking any of the instructions, suppose I am taking add ax comma bx, or I am taking move ax comma bx, or shift left R1 register. So any of the instruction you have to mention what is a process. So it is a program. It is a program. Set of lines are there. Suppose I am taking into 03. Add ax comma bx, move bx into 03. So it is a program. So this residing in a memory unit of a computer. So it is definitely we have to go to the memory with a particular address. So every program we need a address and a memory, and it is consist of a sequence of instructions. Add ax comma bx is one instruction. Move bx comma bx, it is one instruction. Into 03 is a one instruction. So how many instructions are in a set of program? So here I am taking one example. It is a 3 instructions are there. So I am calling as it is a program, and these instructions executed by the processor by going through a cycle of each instruction. First cycle add ax comma bx, move ax, then it is going to the into 03. So it is the last one. So it is also called fetch, decode and execute. So suppose I am giving first step add ax comma bx. It is fetching means it is going to the memory. It is going to the memory and it is checking whether this program is there in the particular memory or not. And decoding. Decoding means it is converting to the binary. Says the program is there in the particular memory, and after checking verification of fetching, decoding means it is converting to the binary. That means machine language. It is going to the machine language. So after converting to the machine language means binary means in the form of 10101010. I'm taking example. So executing this program, add ax comma bx, move ax comma bx into 03. It is executing. After the execution, it is asking enter a value and giving a equal to 4. After then asking enter b value, b equal to 3 I am giving. So when it is asking a value and b value, that means the program is executing. So the proper address is there and the proper data is there. That is fetching, and after the fetching, the data is converted to the machine language. Our program is a high level language converted to the machine language. This machine language is executing. After the execution, it is asking the values, a value and b value. And it is a basic operational process of computer in which a computer retrieves a program instruction from its memory that determines what actions the instruction dictates the carries out of these actions. So instruction cycle, fetching, decoding and executing. Okay, these are the 3 major things. Another I am taking as a fetch operand. How we are going to do the operation of fetch. So fetch, I need memory with address. Memory with address. Then only it is going for the fetch. So the basic computer, each instruction cycle consists of the following phases. Fetch means fetching means reading the next instruction. Reading the next instruction from the memory into the processor. That is an instruction from memory. Decoding, the instruction calculate the effective address. So I am giving add ax comma bx. It is going for the next instruction of this one. So it is the fetching of the instruction, and decoding means it is going to the calculating the effective address of this instruction. So it is enter to the memory. After that, it is entering to the address. So read the effective address from the memory. If the instruction has an indirect address, that is a fetch operand, not a direct address. Indirect address, there it is going to the fetch operand. That is going to the execute. Execution means interpreting the opcode and performing the indicated operation, that instruction. Okay, add ax comma bx. Add ax comma bx. Opcode operand. So opcode is a instruction. It is a instruction. Okay, operand is a memory or address. Okay, so here execution means interpreting the opcode. Add is a opcode and performing the indicating operation of the instruction. What is the operation? You need addition. So if at the time of addition means it is a arithmetic. If I'm going for the logical operations means OR gate, logic gates I may have to use. So every different process has its own different instruction cycle. So execution means I need a opcode to perform the what is the instruction to going for the operation of that one. So fetching, decoding, fetch operand and execution. So it means reading the next instruction from memory into the processor, and decoding means the instruction and calculate the effective address. Read instruction EA from the memory instruction has the indirect addressing mode. Fetch operand means when I am going for the indirect addressing mode, then only I need. And execution means interpreting the opcode of this one and performing the operation of the instruction. So fetch instruction. Next, decoding means converting to the binary. After the binary, it is a read address from memory. Okay, what is the address of the particular memory or data? Then it is going for the execution. Ready execution means ready to go for the output. After getting the output, again it is going for the next line, means next instruction. Okay, move x comma bx I gave. So it is completed. After then it is going to the add. After then into 03. So every instruction I need a fetch, decode and read or write to memory, executing the instruction. Read address from the memory and MAR, memory address register, memory data register. So every instruction I need memory data register and memory address register, and it is executing the instruction and going for the fetch instruction. So instruction fetching. In this phase, program counter plays vital role. Program counter is a register which stores the address of the next instruction to be executed, and hence depending on the value of PC address is sent through the address, but also the memory and then specific instruction is sent back to the data bus. Suppose in this phase, program counter is a vital role. Okay, up to now we discussed only instruction register IARE. Okay, after that I am going for the PC, that is a program counter. Program counter. So program counter is a register which stores the address of the next instruction to be executed. Hence, depending on the value of PC address, it is sent to the address bus to the memory and then specific instruction to the data bus. Okay. Suppose I am going for the any of the instruction, it is going to the address bus, then data bus. So why we are need means I am going for the fetching the instruction. So suppose program counter PC 1000 I gave, the address bus is going to the memory. So is the value, the program counter is there in the memory? Yes, it is present. Then only it is fetching. Then it is fetching the address to the data bus. Okay, if the memory, the particular data is there, fetching means it is searching the particular data is there in the instruction register. So instruction register means searching the memory. The particular data is there in the memory. So how can I search means I am going for the address bus. Okay, it will be finding out the particular address of the memory. So memory is a lot. How can you find out the more than a lot of data? So I'm using an address bus to finding the data in the memory. So it is going for the fetching. Okay, program counter is 1000, address bus, then going for the data bus. So every program counter, address bus and data bus are must to fetching the instruction. That is a program counter. So instruction decode. After fetching the instruction, it is decoded by a user-friendly language or machine language which is familiar to the processor of computer. Okay. Suppose I am going for the move AX, BX, add AX, BX into 03. Okay. Is it instruction? Yes, everything is an instruction. There are 3 instructions are there in a program or in a opcode. So after the an instruction, the decode the user-friendly language or machine language. Okay, every instruction we have to convert to the machine language. So what is this language? It is the assembly language. high level language, low level language, or assembly language, converting to the machine language. That is called the binary. Okay, high level language or low level language is converting the binary in the form of ones, like this. Okay, so it is a machine language, means our user friendly language means high level language or assembly language is converting to the machine language, that is in the form of machine language, means that is in the form of binaries. Okay, so any of the fetching of the instruction, decode means fetching means it is going to the memory and particular address, and it is fetching the data related to your instruction, and it is converting to the decoding means it is converting to the binary, that means user friendly language or machine language, which familiar to the processor of a computer system. And instruction execution, once the instruction gets decoded, the processor executes the instruction in the phase the processor performs the action specified by the given instruction. After completion of instruction cycle, program counter is incremented by 1. In this way, again a new cycle starts and goes on the same way until all the instructions are executed. So after converting to the binary means machine language, after converted to the machine language, decoded means machine language, the program will be executed, it is ready for execution, and this is given by the instruction. So the instruction is ready for execution, after the, when it will be executed means after it is converting to the machine language or binary language. After completion of instruction cycle, the program counter, suppose I am giving move ax comma bx, add ax comma bx, so into 03. So where is the program counter now? Move x comma bx. So is it binary converted? Yes. Next it is converted to the PC. So after, what about this one? It is a PC plus 1, means PC presently it is ready for execution. Add x bx is ready for execution. It is a program counter. PC plus 1 means it is ready. Next instruction is ready for execution. That is a PC plus 1. So every instruction cycle, the program counter is incremented by 1. PC plus 1, like this. And in this again a new cycle starts, goes the same way until all the instructions are executed. So components, program counter and instruction counter take the track of the memory address of the instruction that is in the holds the address of the instruction to be executed in the next. So program counter counts or track the memory address of the instruction that is to be executed in the next. So next instruction to be executed, it holds the address of the instruction to be executed. So I need a address for this one. So address will hold of the next instruction. And memory address register, any of the instruction, suppose I am giving add ax comma bx. Shall I need address of this memory? Yes, I need a address. Okay. So suppose I am taking add ax bx, means I am going for the arithmetic operation. Shall I need, is it a data? Yes, it is a data. Shall I need a memory? Yes, I need a memory. Shall I need address? Yes, I need address. Okay. Anything of the instruction, I need memory address register, memory data register. Then only it is going for the execution. If you don't have any address, any data of the particular instruction, we can't execute of this one. So memory address register holds the address of or block the memory of reading from or writing to the memory. So memory data register, a two-way register that holds data fetched from memory or data waiting to be stored in memory. This is also known as a memory buffer register. So presently address add ax comma bx is going to be executing. So shall I call, is it going to be executing? Executing means it is also called loading. So that is called the buffer, memory buffer register. Buffer means it is going to be execution, or it is going to be loading of that one. Okay, that is a buffer. So memory address register, memory data register, which can be buffering. And instruction register, a temporary holding ground for the instruction that has just been fetched from memory. And control unit decodes the program instruction in the IR, selecting machine resources such as data source, register, and a particular arithmetic operation and coordinates activating of these resources. And arithmetic logic unit performs mathematical and logical operations. Floating point unit performs floating point operation. So control unit means memory address register, memory data register. It can be going for the instruction register. The instruction register which have the address and data, and it going for the execution. That is a control unit. So control unit is for fetch, decode, and execute. All are under control register. Will monitor all those things. So control register will find out the address of the instruction and the data of the particular instruction. It is about the control unit. Arithmetic logic unit means add ax comma bx. Is it arithmetic operation? Yes, it is a arithmetic operation. So arithmetic logic unit will perform the arithmetic operations or logical operations and or NOT gate like this. So these are the logical, and performs the mathematical and the logical operations of floating point unit performs the floating point operations. So it is the start source count SC. It is program count tends to AR register, and a memory address register tends to the IR. PC plus 1 means suppose IR register is there. What is the program counter now? What is the next line? PC plus 1. Suppose I am going, first line is a move AX comma BX. Next line is a add AX comma BX. So what is the present going on? Presently loading function is a PC. After it is going to be loading. That is a add AX comma BX. Decode operation from IR register and AR instruction register to address register. It is instruction register to I means interrupt function. Okay, if I equal to 0 means though there is no interrupt, I equal to 1 means there is a interrupt is there. So going, I am totally going for 0 to 15. Okay, so 0 to 15 is the IR function. In the 0 to 11 is the instruction register or address register. 0 to 11 is the address of the instruction. Next 12 to 14 are the decode or opcode. 12 to 14 is the opcode, and 15 is the instruction register. Totally 0 to 15 is the IR. Okay, so in the 0 to 15, 0 to 11 is the here 0 to 11 is the address or IR instruction register. 0 to 11. 12 to 14 is the opcode. What is opcode function here now? Add AX comma BX. So add is a opcode. Move AX comma BX. So what is the opcode function? Move is a opcode. Okay. So 15th is a interrupt. I equal to 0 means there is no interrupt. I equal to 1 is there is a interrupt is there. So like this. Then if it is 0, then memory reference. If it is 1 means it is going to the register. Then it is going to the input output. If it is 0 means directly going to the register to execute. If it is not a 0 means it is going to the input output operation and going for the execution. If it is means indirect to function or direct to memory. Direct to memory means is equal to 0. Indirect to memory means it is going to be 1. So memory address register of address register. It is a direct to memory means there is no need of any address. Directly it is going to be execution. Indirect address means it is going to the particular address and particular data, and it can be executing. Okay, it is about the instruction cycle. And address register is initiating with the PC. Okay, first T1 cycle, what will happen? It is fetching from instruction. Okay, in the T2 means it is going for the decoding. In this fine, decoding after decoding, fetching, decoding, and it is going for the execution. First T1 function fetching, T2 decoding, T3 function executing, or T4 function also executing like this. Okay, so it is about the function of each one. Direct to memory instruction T4 is the execution of instruction, indirect memory, direct memory or indirect memory. If it is indirect memory means address register we need. After then it is going for the instruction. If I going for the input output function, then it is going for the source index, then it is going for the execution of the instruction. Okay, these are about the references. So we are discussed about instruction cycle. So in the instruction cycle, a program residing in the memory unit of a computer consists of a sequence of instructions. These instructions are executed by the processor by going through a cycle of each instruction. That is a fetch, decode and executing of this one. So this is a basic operational process of computer. And what is the fetching means? We are fetching the instruction from the address and data. Decoding means it is converting to the machine language, and read address from memory. Okay, the particular instruction is there in the available in the memory. As it is available, then it is going to the memory and executing the instruction. After that, it is going for the final. So next line is a next instruction is there, fetch, decode, execution. So like this. And instruction fetching means program counter vital role will be play here. So PC means when it is going for the loading of instruction. Okay, so that is a program counter is a register which stores the address of the next instruction to be executed. It is depending on the PC address is sent through a address bus and the specific instruction to be going to the data bus. Okay, so program counter means what is the instruction to be executing, to be loading. Okay, and taking program counter is 1000. So it is going to the address bus and searching a data through a address bus. It is going in a memory and it finding out the data, the particular data is available in the memory or not. If it is available, it is going to be executed through the data bus and fetching instruction. Or next one, it is going to the execution. After fetching the instruction, it is going to be execution. Okay, in the decoding means machine language means after the completion of fetching, decoding means it is converting to the machine language. Machine language means binary language. Okay, every instruction move x, bx, add into 03 like this. Any of the instruction converting to the binary. So that means high level language or assembly language is converting the machine language in the form of binary. Instruction execution means it is decoded. After then it is completion of the instruction. Program counter increment by the new cycle start goes into the same until the instructions are available. So every instruction first execution fetching is completed and decoding is completed, then only it is going for the execution. Execution means going for the output. And the program counter, memory address register, memory data register and instruction registers are the components of the instruction cycle. And the control unit will finding out about the memory address register and the memory data register of the instruction register. And arithmetic logic unit will perform arithmetic operations and logical operations of the instructions. It is a flowchart of instruction cycle about arithmetic logic unit and instruction register and the program counter, all those things. So it is about the time duration. First time pulse T1 fetching, T2 it is going for the decoding, and T3 to T7 it is going for the memory address, going for the address and fetching the memory and executing all those things. That is a D0 to D7. So last execution is a D7. Okay, everything, each cycle clock pulse what is happening here, that is be showing here. Okay, it is about the instruction cycle. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.